Hello students, today we'll be starting with the new unit, that is reservoir and dam planning. Now what is a reservoir and dam we have discussed in the previous lecture. Okay, so here we will be taking a deep dive into how a reservoir is actually planned. So with this, let's get started. So as you know that there are about 9 subtopics in this chapter, so we'll be discussing all of them. So first we'll start off with selection of a site for dam or a reservoir, okay, classification of reservoir, and then we discuss about the various zone in a reservoir. By the way, if I have to give you a basic difference between dam and reservoir, like I have also explained in the previous lecture, dam is the man-made structure, whereas reservoir is the pond that is formed after the construction of dam. So this is reservoir, and this concrete structure is what we call by dam. Okay, so that is the difference, and usually both of this will exist together because without dam there cannot be a reservoir. And then we'll discuss about the design capacity of a reservoir and draft efficiency and the sedimentation losses and preliminary investigations, and followed by that we'll also do basic classification of dams and selection for type of dam. So this topic comprises the unit. So let's get started with the first, that is selection of site for a dam. So as you know, there are many factors that needs to be considered while we select a site for a reservoir or a dam. As I said, dam and reservoir, we take it together because without dam, reservoir cannot be formed. So we also have to take into consideration for the factors of dam construction. So the first one on the list is large reservoir capacity. So when we plan for a dam, it has to be such that the reservoir, that once we construct a dam, after the dam is constructed, so you can look over here. Okay, so you can look over here because I'm going to write many things here. This is my blackboard. Okay, all right, so once we construct the dam here and the reservoir capacity is very less, then the purpose of constructing a dam over this site is defeated. We also have to take into consideration that this reservoir can hold large volume of water. That is the main purpose of a reservoir, which means we are storing some water. So that is the first one. And next one on the list, as you can see, 1.2 is, let me erase this first, and 1.2, as you can see, is the suitable site for the dam. Okay, now when we talk about the suitable site, the first and the foremost thing that comes to mind is the good foundation. Okay, the geological formation has to be such that it can withstand that massive structure. And usually if the geological formation is not so good, then what happens is it affects the stability of the dam, and dam may not be stable. There would be a chances of dam collapse. So this is the one of the most important factor, and the live example of this is Puna Chanchu project 1, the found with the site at which there was first they planned about the dam. They found out later that geologically that region is not so stable. So we know from that experience that how important it is to do the preliminary analysis in detail. Okay, so that is one important factor. Next one is the water tightness. Now water tightness means main function of a reservoir is to store water. Now if the geological formation, for instance, let's say this is our profile. Okay, this is our profile, and here we have constructed the dam. All right, there's a dam here. So, and there will be the reservoir. Yes, if the geological formation of this region, it's not very strong and hard. Now I'm using this hard and strong term very loosely. What I'm trying to tell you is, if it is not watertight and it lets water to pass through, what happens is there will be lots of seepage. Okay, there will be lots of seepage, and because of this seepage, the water, it cannot store water for a longer duration, and also it affects the stability of this dam. So this because of these factors, we also have to take into a very close look into the geological formation. Usually it's said, it's the pervious rock. Pervious rock means this geological formation of the rock which is having a large capacity to let water pass. So that is what we call pervious. And the reservoir basin having slates, how to pronounce this, slits, gneisses and granite are generally suitable. Okay, so these are the conditions. Next one is hydrological conditions. Hydrological condition means let me get rid of this first. Okay, hydrological condition means whenever we discuss about the hydrology, the term catchment gets associated with it. So let me first explain you the meaning of catchment. Okay, if you just trace a river, let me use a different color. Okay, if you just trace a river, and river will have its tributaries, right? And all the rain that gets into this streams, and eventually it gets into one's common outlet, we call it the catchment. And if you trace that line, it will be something like this. Okay, so basically what I'm telling you here is all the rain that occurs within this boundary eventually gets into one common point known as outlet, and this area is known as catchment. Catchment, or sometimes we call it as basin, river basin. Okay, so if you construct a river whereby the catchment or the catchment or the basin is very small, and it cannot, we have constructed a massive reservoir, but that reservoir is never going to be filled with the water that is getting drained in from this catchment. So there is some failure in the planning, right? So that is what a hydrological consideration means. Okay, hydrological condition means. The next one is pretty simple. This is from the property of water, that deep water tends to evaporate less compared to shallow water. So usually deep reservoirs are preferred because there will be less evaporation losses, and we need to minimize this loss from the reservoir as that is not desired. Okay, next one is small submerged area. As it's very self-explanatory point. Now if you construct a dam that can submerge the entire city, who wants to build a dam there? It is a stupid idea to construct any dam that is going to submerge the whole area, right? So, and moreover it's going to be extremely costly because you have to evacuate all the people from that region. Low silt inflow, these are also factors, but usually if we rank the importance of factor, the silt will come in a very low in the list, because all the river mostly carries the silt. Most in the Himalayan rivers, or Punachanchu, Wangchu, all of this carries tremendous amount of sediments. Now we cannot directly omit this. I mean, we cannot give so much a priority for this, because there are other important factors, but this is also to be considered. Okay, if there's a possibility to remove the silt by some ways into the river, then of course that kind of strategy is planned while constructing the dam or the reservoir. So no objectionable minerals. Now what happens is, in some geological formation there could be some minerals. Now if you construct a reservoir over there and this mineral gets dissolved, then there's a chances that it might harm the aquatic life. So that is not desirable, and we have to avoid such sites. And low cost of real estate. Now low cost of real estate means if a river is flowing between a city, and that if we want to construct a dam, then the price of land in the city is way more than the price of land in a remote area, right? That we know it, right? So usually that situation is avoided, because then you have to compensate the land for the landowners, and it's going to be very expensive. So usually that seldom happens, but that is not desirable. Okay, so these are the selection selection of site for a reservoir. Okay, these are the factors that should be considered while selecting a site for a reservoir. Now let's talk about the classification of reservoir. Now in Bhutan, strictly speaking of Bhutan, we have only constructed reservoir for one purpose, that is hydropower. But elsewhere in the world, there could be many other purpose of a dam or a reservoir. It can be constructed for irrigation purpose, right? Now, or for domestic water supply for a city or a town, for industrial use, for navigation, right? You can give a, I believe you know this for construction of dam for navigation, right? There's an example in Middle East. Please go and find out, okay? And storage space for flood control. What people do is, in a very flood prone area, they construct a dam so that when a flood arrives, that reservoir has the capacity to hold the water for some time, and they will regulate the flow so that downstream is not flooded, okay? And reclamation of lands, debris control, and preservation and cultivation of useful aquatic life and recreation. So these are the various types of reservoir, okay? The classification of reservoir. And also, depending upon the purpose, it is said that it can be classified into 4 categories, okay? All these can come into these 4 categories. One is the storage or the conservation, another one is flood control, distribution reservoir, or multi-purpose reservoirs. So let's go and check it out what storage and conservation reservoir means. As the name suggests, it is used to conserve the water. It is used for now let's take an example of scenario of Bhutan. So most of the reservoir in Bhutan are not of the storage type, because we do not store water for a very long duration. There could be some other dam where dam is constructed to hold on the water during summer to be used during winter, okay? This is one type of reservoir. The distribution reservoir is, these are small size, okay, for basically for supply of water in a city. And there is flood control. So as you can see, as like I have also explained, now let me explain technically with the help of a hydrograph, okay? A graph that is plotted between time and a discharge flow rate is also known as discharge. Q is known as the discharge hydrograph, okay? So now what happens is, if you construct a dam, like I said, if there was no dam, the hydrograph would go something like this, right? The red one. But if you have constructed a dam, the large volume of water gets ponded into this reservoir, you can see here, right? So what happens, this peak can be reduced significantly, and the recession limb of a hydrograph, it can be controlled to pass a little bit more, but this volume of water will not cause any flooding in the downstream. So this way we can save the downstream region. Okay guys, so with this I would like to stop my lecture here, and we'll continue in the next session. Thank you.